So we just determined that electrons influence reactivity, and they do this through bonding. So let's talk about the different types of bonds. We know that atoms can come together to form molecules. They can do this using either ionic or covalent bonding. In ionic bonding, one atom wants electrons so bad that it completely snatches or steals or transfers an electron from another atom. And this is the case right here in table salt. If you look at sodium and chloride, the two atoms that make up the molecule NaCl, or the common table salt that we know, you notice that sodium has one electron in its valence level. Chlorine, on the other hand, has 7 electrons in its valence level. So chlorine only needs one electron to have a full octet of electrons, so it is extremely electron hungry, or a term that we use called electronegative. So electronegativity is basically how hungry an atom is for electrons. So chlorine, who only needs that one electron to have a stable octet, is extremely or highly electronegative, while sodium would actually rather get rid of that one electron so that it can have an octet that is depicted right here where my cursor is. So sodium in this case has a low electronegativity. It does not have a strong desire for electrons. It would rather get rid of the one in the valence level, while chlorine has a high electronegativity and only needs one electron to have a full outer shell. So basically this electron is going to be transferred over here to chlorine, and we call that an ionic bond. Atoms can actually share electrons in another case called covalent bonding. Look at the prefix co, like cooperation. They're working together. So in the case of water, we have covalent bonding. We have oxygen that actually has 6 electrons in its valence level, and hydrogen that only has 1. Well, if they come together, an oxygen can covalently bond with 2 hydrogen atoms and form the molecule water. And if you notice, hydrogen is happy because it has 2 electrons in its valence level. This hydrogen is happy, of course, because it has 2 electrons in its valence level. And oxygen is happy because it has 8 electrons in its valence level. So covalent bonding occurs when they kind of have similar electronegativities. They both want electrons. They both would like to share these electrons. Well, there's 2 types of covalent bonding, polar and nonpolar. In polar, what happens is that both of these cases, they are sharing electrons. They are sharing these electrons. Well, the question is, are they going to share them equally, or is one going to get more electrons than the other? In the case of water, you notice that the majority of the electrons are up here. While there are still some electrons down here, the majority of them are up here. Well, we know that electrons have a negative charge. So if the majority of the electrons are on this side, it causes oxygen to have a slightly negative charge up here and hydrogen to have a slightly positive charge down here. Now remember, the key concept here is that they're both, in this case, they're still sharing the electrons. It just so happens that more of the electrons are concentrated up here rather than down here. And so that creates a pole similar to like the North Pole and the South Pole. And that's why we call it a polar covalent bond. In this case over here, however, the electrons are distributed evenly. So each of these, there's not a place where there's a higher concentration of electrons versus another place. So when the electrons are shared evenly, you consider that a nonpolar covalent bond. A result of polar bonding can be seen in hydrogen bonding. Hydrogen bonding occurs when the slightly positive hydrogen atom of one water molecule is slightly attracted to the slightly negative oxygen atom of a different water molecule. And so as you can see right here, you have some attraction going on between molecules. The key concept in hydrogen bonding is that you need more than one molecule. You're not talking about attraction within the same molecule. You're talking about when the hydrogen atom of one water molecule is slightly attracted to the oxygen atom of a different molecule. Don't get that mixed up on your test. Well, depending on how these electrons come together and bond, they will have different shapes. And the significance of this is the molecular shapes influences the smell. So if you ever wonder why some things smell good to you, some things smell bad to you, it has to do with the shape, the shape of the molecules and how they hit your nose receptors. So that's just a cool tad bit of information. The last thing that we're covering in Chapter 2 is the concept of solutes, solvents, and solutions. Remember, solutes are usually the solid, so like the salt, the sugar, the Kool-Aid mix. The solvent is what it is dissolved in. It kind of sounds similar to me. Solvent dissolved in. So you have your solute, which is a salt, your water, which is a solvent. If you mix that up together, you can get salt water or a solution. So the solution is just a mixture of the both. All right. And that basically covers Chapter 2 right there.